Good morning, and as always, slow is smooth, and smooth is fast. So what I'm going to go through today is types of bonds, but before I do that, I want to kind of do a quick rundown on remote learning. I'm going to be looking for your engagement over the course of the next couple weeks. I'm going to be reporting to Taft who's engaging in the content and who's not. I'm not sure exactly how they said that incompletes may be given out. I don't know what that means exactly. I imagine that we'll have more guidance as we go through this process. Understand it's all very new for a lot of different people, but you are expected to engage in some way. I am expecting to hear from some of you. If you guys need different materials than what I'm providing, please let me know. I've had some people reach out, and so I'll also be posting my videos on YouTube. Hopefully that helps with access in anybody that might be having an issue. I'm going to start walking through types of bonds. This is going to be assignment 5 on Google Classroom. So we're looking at single bonds, double bonds, and triple bonds. We're looking at resonance. And we're also looking at polymers. So this is getting more into chemistry that has a real grounded reality in what we use on a daily basis. So single bond, double bond, triple bonds. A single bond shares 2 electrons. So 2 electrons are being bonded together. This is going to be so this is your note. This is going to be the strongest of the 3 bonds. The triple bond is the single bond is the strongest single bond. But as you add more bonds as we go, the collective gets stronger. So this single bond is the strongest single bond, but the other bonds are actually going to be stronger. A double bond is when 4 electrons are shared. So we can put here that when 4 electrons are being shared between the 2. So that means that 2 bonds are sharing because each bond carries 2 electrons. And then the triple bond is when 6 electrons are being shared. So you have 3 bonds that are being shared between the 2. So we'll draw those in real quick. So we have our bond between here. We have our bond between here. Bond, bond, bond. Looks like I forgot to draw that one. All right, so we have our bond. So we have 1 bond, 2 bonds, 1, 2, 3 bonds. So resonance plays off this idea of single, double, and triple bonds. So there are some that are going to be in between. So there are several similar setups in certain situations where the bonds are close to one another. It's a situation where one could form a double bond and one could form a single bond. But how do you pick? If you have 2 different things that could happen, how does the compound pick which one will happen? And they don't. They don't pick which one will happen. They kind of have a collection that both are happening at the same time. So for example, NO3 minus 1 has 1 extra electron. So that minus 1 means it has 1 extra electron. It's going to get into a situation where it wants to form 8 around its outer shell, remember? So everything wants to form 8 electrons in its outer shell. It can either share them to do that, or it can get there on its own. So as we start to share these, it doesn't work out. Even if we throw in this extra one, it doesn't work out where we're just bonding to the center point. So this is actually going to form a double bond. This is going to form a single bond, and this is going to form a single bond. Now you have 1 extra electron on the top here, and it's going to say, okay, well, I'll give that one to this, and that's happy. And then this extra electron gets put onto this one, and then that's one is happy. So really we have this compound that looks like N, O, O, O. And I'm removing the other electrons to kind of decrease the noise. So we have a double bond, a single bond, and a single bond. Or we have a single bond, a double bond, and a single bond. or we have a single bond, a double bond, a single bond, a single bond. All three can happen, so all three do happen. So we see resonance occurring where all three of these states happen at the same time. So the note here is that resonance, all three states are happening at the same time. Last note is polymers. Polymers are long chains of compounds, typically starting from some kind of double bonded format where then the electrons can then make changes. So long chains of atoms in a row are put together. This is the thing that we're seeing mostly in our daily life. Plastics are all polymers. RNA, DNA is all polymers. So polymers are all around us, and they're making connections with the things, making long strands of connections from small subgroups. So we go from having just two atoms in a chain to having chains that are hundreds, thousands of atoms long, and that gives them a lot of strength, elasticity, and durability. Last thing, what's due? You're going to draw out the Lewis structure, the structures for 5 different compounds, and then you're going to identify 5 things around your house that are made out of polymers. If you're struggling to find anything that's polymer, there's the crash course video. He goes over 10 examples, so you can just go and watch that video and then pull out examples if you're struggling to find and document which ones and how you know. So you're identifying and you're explaining how you know. So I don't just want a list of 5 different things. I want to say, okay, this is the thing that I think is made out of a polymer, and this is why. Yeah, I hope everyone is well. I'm going to set up a Google Meet. I'm going to put a form on this to see if you guys are willing to meet in the afternoon to kind of reduce the workload on all the different parts. But I'll have a Google Meet set up so that you guys can ask questions about this, and we can go through some of these examples or similar examples so you can do them on your own. All right? Hope everyone is well. Please reach out if you have questions. Please reach out if you have concerns. That's why I'm here. I'm here to help. All right. Thank you.